Late last year, I finally decided to pick up some RC cars. I never really had any growing up, but I've always wanted them, and most of my hobbies revolve around cars in some way. I was drawn to the Arrma lineup right away, so I grabbed their Typhon and Mojave BLX Groms. I was shocked with their performance. I really had no idea that these little machines could do this kind of crazy stuff. I continued looking into other RC options, and I found that most RC car bodies are made for 1/10 scale with the 257 millimeter wheelbase. But I struggled to find a chassis with that wheelbase that could also handle the abuse like a Grom can. So my solution, modified Arrma Grom BLX to 257 millimeter wheelbase. That way I can fit any 1/10 car body that I'd like. I like that the Grom BLXs come with metal parts like the differential and the axles. So I narrowed it down to the Mojave Grom BLX and the Typhon Grom BLX. Looking at the Mojave Grom BLX here, you can see it has a pretty straight chassis. There's no weird curves along the sides. I drew these red lines in to show what I'm talking about. But if we flip on over to the dimensions, we're going to see it's got a wheelbase of 196 millimeters, but a width of 172 millimeters. Now, if we take a look at the Typhon Grom, this one also has a 196 millimeter wheelbase, so I'll only need to extend either one of these by 61 millimeters. However, the key thing is it has 188 millimeter width. Now, this is important because most 1/10 cars are 190 millimeters wide. I could go 200 millimeters by swapping in the granite arms on this as well. One downside with the Typhon are these shapes on either side of the chassis that I've highlighted in red here, but I think I should just be able to cut right through these. They're not really important to the structure, and that leaves me the entire central tub still. Here I have chopped the chassis in half. I just simply went at it with a rotary tool and a cutting disc. I could have done it a little cleaner. I did lose a little bit of distance. Now, the goal is going to be to put these halves together. To do that, I have designed these parts in CAD. This top brace is going to be the center one. It runs down the middle to combine the two chassis halves. It's going to be made out of 7075 aluminum. And the bottom part is going to be made out of acrylic. I'll have two of them, and they'll sit on either side of this brace under the chassis. And you'll see a mock-up soon enough to know exactly what I'm talking about. Beyond that, I did create this jig thing that I also had made. It didn't turn out so great. It wasn't the smartest thing, but I was just kind of testing things out, so I went with it. Here is the delivery from Send Cut Send. They did not sponsor this or anything, but I just think they did a great job. They packaged things well. They gave me some extra candy, but all the parts were nice. And here I'm going to bring up a clip that shows you the brace. And this has a wrinkled powder coat, which is very durable. The dimensions match very well to what I specified. Overall, I was very happy with what they created. Here's the mock-up that I was talking about. I've laid that center brace down across the two halves and these two outside Lexan braces. They just have some paper over the top that I'll remove later, but these are going to be screwed in. I have two holes on each end of the Lexan and then 5 on each end of the aluminum brace. I will be screwing these in. However, I will be first adhering them with some JB Weld epoxy. Then I'm going to screw them in place, and that's going to make sure they never come apart from the chassis. Here is the main center brace. I have countersunk all the holes. I'm going to tap these into the chassis so I can screw them in for added strength. But first, I'm going to epoxy them to the body. So on the flip side here, you can see I have scuffed up the bottom to rough them up. That's going to really help the JB Weld epoxy adhere. And here you can see the JB Weld that I'll be using, the standard stuff. But you really want to make sure that the surfaces are rough or it's not going to adhere very well. Before I continue on to the next step, I just want to show these drawings of a drive shaft that I made. It's actually two. The top one is a little different. The bottom one, you can see, has a circular center portion with the hex only at the end. I had these 3D printed, and you'll find out what happened, but ultimately it didn't work out, and I had to come up with a metal solution. Here is a 3D printed drive shaft with the gear assembly, the spur, and outer pinions put on, installed.
This is the original drive shaft right here, and this is the extended one that I had printed. So here you can see the original. This is one of the 3D printed versions, and you can see the quality, surface quality is pretty rough.
Here's the chassis and all the parts I'm going to use to put it together. I've scuffed up both halves here, as you can see, as I did with the center brace, and you can see it's going to go in place pretty much right here, this way around. And this is important to make sure I can access these screw holes, same as with the Lexan. I've also scuffed these up, and you see when I put it in place, it leaves access to the screw hole, which holds the receiver on, something like that. So these will be in place, aligned a lot better than they are right now, but just kind of showing you where they go. The drive shaft is going to be in place. That's going to help me align the two halves a bit better. But ultimately, I'm counting on the jig to help me get everything in line, and it worked for the most part, as you'll find out.
And here is the chassis all set up on the jig, with the brace just kind of set on there for now. It's not affixed, but that's where it's going to go, essentially. I feel like things are, pretty level. I'm definitely doing a lot of eyeballing here. So now I'm going to whip up some JB Weld epoxy and glue it up, hope for the best.
And here it is with the JB Weld epoxy applied. I've affixed the center brace and the two side Lexan braces. I really think it all looks pretty good, so I'm going to let this dry, cure for at least 24 hours before I handle it. Here is the chassis after 24 hours or so of curing time, and everything feels very sturdy. I can shake it around. There's nothing loose, no cracks or anything, so the epoxy seems to be doing its job. Next, I'm going to tap these 4 holes, or 5 holes, as well as the 2 on each end of the Lexan braces, and install some screws. That's going to really hold this in place. I will even epoxy those in. The next thing I'll do is add some epoxy around the edges of the braces to help kind of build it up. So I'm going to build it up along the edges of all the braces in a similar way. Flipping it over, you can see the hole in the top deck. It doesn't quite align, doesn't matter, but I need to fill this in. I will end up using Lexan sheets and the epoxy to help fill it all in and make a fully sealed tunnel, as well as sealing in the chassis with some Lexan plates and again the epoxy. So that will happen later down the line. But first, my goal is to tap these holes and get everything epoxied so this chassis is functionally ready to go, so I can test it out as soon as possible. Here is the chassis, and I have installed the screws, as I mentioned. Those have epoxy inside the screw holes as well. I've also added up a bead around the edge of where the brace meets the chassis to help add some strength, and it seems to have done pretty well. You can see up close here, it's not very pretty, but it is functional. This seems very strong, very confident in it. Now that the bottom is all in place, I think it's going to be ready to set up and take it for its first run. I'll probably start out with the standard DB Boots tires. I do need to replace the suspension because one of them broke, during initial testing with the car. But I have these cheap Nex suspension. They actually turned out pretty good. Going to put those on. I also have a brace plus some other parts you'll see later on. And then otherwise I've got the drive shaft that I made up, and then I've got this case full of all the parts to put it all back together. I'm going to try that now. I just want to share something I found with the pinion gear on the stock motor. This is the brushless, of course. It was actually seated far back on the shaft, so it was only engaging with about half, and you can see I still don't have it quite far forward, but you might be able to see on the teeth. Yeah, I don't know, it wasn't engaging fully. I thought something was wrong, but I looked at this other, one that I'm using, and I could tell, yeah, the spur gear or pinion gear, whatever, the spur gear is a lot more forward than it was on this one. So factory defect. It ran okay, but it's going to put a lot more wear on the edge of the teeth, I think, over time. So this way it's got a lot more contact. Hopefully helps things out. And so I've hooked up the electronics, got the battery set up with these extension cables, because the stock ones are just a little too short by like an inch maybe. So now I'm going to go ahead and try it out. Got a battery hooked up. I did notice, as I spun the shaft myself, it's kind of rigid. Hopefully things are not misaligned, but that might be a sign. So let's see how it runs. That was only at a fraction of the throttle with it set to 50%. It's pretty loud, so we'll see how that goes. I also do have the Yeah Racing fan in here, which is quite loud, so you're hearing that too. But it seems to be very cool, so I recommend them, and they fit inside the original casing, the 25 by 25 by 10 Tornado, I think it's called, from Yeah Racing. But yes, here it is, and you can even see it next to a regular Typhon, just how much more length has been added on, quite a bit. Interesting seeing them side by side. So just need to go ahead and hook up a battery, figure out a way to mount that down, and that should be good. It's a little too much fun, I'm finding already. So I got it at 75%. I'm going to bump it up to 100 now and see what happens. Oh well, if I snap something. Still going to take it easy off the line and stuff, but show that this thing should still be able to bash pretty hard. This is with the Pet G Plus, or the PLA Plus drive shaft. %. And stop. So yes, can't take 100%. This is 2S with the PLA Plus drive shaft. Get it nice and straight. It's a little bit of trim.
at 100% and see how that goes. I have disassembled the chassis for now. All the components, electronics, whatnot removed. The next focus is going to be on these parts, the top deck. I cut them at different areas so the gap doesn't quite align. That was because of, this mounting point, and it just seemed like the best way to get the most mating surface. I have about this much and this much on each side, so it's pretty equal. And I've got these Lexan plates. They're going to go across, and across the back, and then I should do the same here, going across, front and back, and I'll probably end up putting in a floor because I don't want a bunch of debris getting in, and likely sidewalls. That'll probably all be Lexan.
Here is the top deck. I have epoxied on the Lexan pieces, so they overlap with the original top deck, and then I have epoxied the pieces themselves together, filling in the seam lines along their edges. I have to turn on the flash as I flip it around here, but you can now actually see the epoxy built up a bit better. This side is got a bit of a different shape. It actually needs to build up even further out. Later on, I'm going to end up putting a lot more epoxy on this and sanding it down, and it makes it extremely rigid. But as it stands, you can see it's pretty strong. This is definitely going to add a lot of strength to the chassis front and back from any kind of hard collisions or hard landings.
Just wanted to show off what has happened to the PLA Plus drive shaft. It's kind of hard to focus on, but let's see. You can make out the twists in the actual plastic. So it looks like it's twisted, I don't know, 90 degrees, maybe even 180. The hex part, this is the circular part. When we go to the other end, this would be the front end. It doesn't seem to have it, so the rear end is taking up all that force, and it's twisted, but it still feels very strong. I'm going to keep running this one while I work on sourcing a stronger drive shaft. I just ripped through a battery pack, still just going with the 2S 30C, standard pack, and it was going really well. It was a lot of fun, and then I started doing donuts a lot, and I decided, after I picked it up to look at it, to actually observe the drive shaft inside. You can see it, and it wasn't spinning, so it must have snapped. Guessing it snapped when I did probably like a 180 turn or something, so I'm going to tear it down and see how this drive shaft looks. Alright, I've unscrewed everything. I haven't taken it apart yet. I guess we'll find out together. The front wasn't going. I could see that the shaft wasn't moving along this area, and I remember seeing the twist in the rear on the shaft, not on the front. So my guess is we're going to find the snap happened back here. Let's go ahead and find out. Let's get this off. It's going to be a little hard with one hand. I'm going to set this down. Okay, so got it popped loose. Let's go ahead and take it all the way off. And up here, we've got, actually, looks like it might have been chewing at it a little bit. But back here, it just kind of popped out. So yeah, definitely converted it to rear wheel drive. With this, let's go ahead and pull the front out, and we can inspect that. Look at the failure here. So this is the PLA Plus. This is the transition from the hex to the circle. So that's okay. So yeah, this end held up okay. Taking a look here. The other end, not survived so well. This also appears to be right at the transition point. You can see kind of separated into threads. I wonder if that's just from like rubbing or if it's some part of the actual like print layers. I'm looking down inside here. Yes, I got some grass inside. Let's take a look. Yeah. I hope my phone can pick this up. Here is the plastic shaft bit that I took out, and what I'm hoping for is to show you the twist on this, because it is pretty funny, pretty extreme. Let's see if I can get some good lighting here. For some reason my phone is really struggling with small objects. But yeah, you can see there's the hole, the opening hole to receive the pin, and it rotated, it twisted over multiple times. So yeah, this won't last very long at all. So here's the PLA Plus drive shaft. You can see this is the front end where the hex area transitions into the circle. There's no twisting at all. All that happened on this end. This is the rear end area. There we go. You can see just how mangled that got. Basically what I expected. So my solution is metal. I definitely want to try a metal drive shaft. It's been hard finding anything in aluminum or steel. Then I realized, there's so many hex tools. So I picked up this Eklund 5/32 15-inch hex driver. So that's going to be my next attempt. I basically should just need to cut it to length. About the length of this, and then drill in the holes at the matching points, and then I should be able to insert this. So I'm going to go ahead and prop this up and do a test fit here. Alright, going to try to insert the pinion onto this 5/32 tool, and oh boy. Yep, that is very snug. Perfect. So now I'll just need to drill a hole in here. Of course, cut it to length over here somewhere, and then drill in the other hole in place to essentially match what's going on here. I don't know how hard it'll be to drill through this material, but I'm going to try. I don't even have a bench or a drill press or anything, so it's going to be tough. Alright. I haven't mentioned yet, pretty limited on tools. Don't have a ton of experience with this stuff, but after looking it up online, a cutoff wheel like this, I guess fiberglass one, came with this cheap Wen rotary tool that works pretty well. But yeah, just cutting through the metal, and it's definitely going well. As you can see, if it focuses. With a few attempts with the little drum grinder on there, I was able to go ahead and get this right down to exactly 238 millimeters, so perfect length. Looks very straight, as you can see along the ruler edge. So hopefully I can drill the holes on each end, and I'll have a nice permanent steel drive shaft. Drilling the holes into the drive shaft proved to be the biggest challenge of this build so far. No matter what drill bit I tried, I was unable to get any further than what you see here. But thankfully I realized I don't even need to drill these holes. The axle will be held in place by the pinions, and those pinions are held in place by the chassis, so the axle can't move out of place. That saves me a lot of trouble. Alright, this is probably asking for trouble. One hand recording 3S with my steel X-Tool drive shaft. Let's see what happens here.
Well, this video has ended up a lot longer than I expected, so I'm going to break it into multiple parts. In part 2, you will see me continue working on the chassis and building up the floor and side plates, and you'll even see me pick up a Lexan body and paint that for the first time. See you then.